Hey everyone, welcome to Chapter 1, Section 3, Locating Points and Midpoint. The first thing I'll start off with is pointing out what it means for a segment to be congruent, or how you would see it, I should say. You'll see congruent segments marked with a little dash mark, okay? Um, so any segment that has one dash mark will be congruent to the other segments with one dash mark. If you have a bunch of segments and some of them have two dash marks, then all the ones will be congruent to the ones with two dash marks, but not the ones with one dash mark or three dash marks, okay? So the dash marks are to indicate congruency to other segments. And the symbol for congruency, when you write it down, is an equal sign, but it has the little tilde or the squiggly sign on top of it. The next thing I want to cover is the midpoint of a segment. The midpoint is, as you might think, halfway in between the endpoints of a segment. Okay, so there's this definition here. If M is the midpoint of PQ, then PM equals MQ, and PM is congruent to MQ. So M is halfway in between P and Q, so this segment PM is congruent to MQ. And you would find it with this formula here. You add together your two x coordinates, so the first x coordinate you see, or the leftmost one, will be the p, or the x1, y1. Of course it's a p, but the ones on the right, x2, y2, that'll be the ones. Yes, the ones on your right are x2, y2. Okay, so you just have to add together your x coordinates divided by 2, add together your y coordinates divided by 2, and you'll find the coordinates of the midpoint. So let's do an example here. It's just a one-dimensional example. Judy's hanging a picture 15 inches from the left side of a wall, and then the other side is 37.5 inches from the wall, so she wants to hang it center. So you just need to know one side's 15 inches, the other side is 37 and a half. So you just add together the two coordinates. Like, these are just x coordinates. That's what I meant by one dimensional. There's no y coordinates given to me. So I just added together the x coordinates and divided it by 2. It's worth noting that you should use parentheses when you're typing into the calculator, because if you don't, the calculator will probably divide 37.5 divided by 2. It'll probably do that and then add 15. So you'll get a different number. So make sure you're doing the addition first and then dividing it by 2. So example 2, find the coordinates of M, the midpoint of ST. S is at negative 6, 3. T is at 1, 0. So let's pull up our midpoint formula. In case you forgot, add together the x coordinates divided by 2, add together the y coordinates divided by 2. Label your points. What's x1, y1, what's x2, y2? The first point that you read is your x1, y1. The next point you read is x2, y2, and so on, okay? So all you got to do is plug those numbers into the formula. So negative 6 over 1 divided by 2. That'll make negative 5 divided by 2, which is negative 2.5. This will make 3 over 2. That's 1.5. So there we go. My midpoint's at negative 2.5, comma 1.5. Just remember, add together your x's and add together your y's and divide each by 2. The next thing we're gonna cover is partial distance. So partial distance uses the distance formula, but you're only going to go a smaller amount. So, right, partial distance. So find x on AF. So here's a picture. That is 1/6 of the distance from A to F. So x is going to be a new point that we're going to put on this number line here. Okay? So I just need to know, what is the distance between A to F? Well, A's at negative 7, F's at 5. So you would want to subtract your x2 minus your x1, 5 minus negative 7, and that's 12 units. All right, if that confuses you, you can always count. Start from A, count, and you'll count out 12 spots until you get to F. So you take that and you multiply it by your partial distance, 1/6. So 12 times 1/6 is 2, but 2 is not your coordinate, okay? Because if you went to 2, that looks more than 1/6 of the distance from A to F. From A to F, 1/6 of the distance should be close to A, not close to F. So what you do is you add that value, you add 2 to the coordinate of A, negative 7. So you get negative 5. So we put a dot right here with x being at negative 5. That's 1/6 of the distance from A to F, okay? So number 4, find r on nm that is 1/4 the distance from n to m. So I give you the coordinates of n and m. So you need to calculate the distance between n and m. So you need to calculate the distance with your x coordinates and your y coordinates. So first I'll start with the x coordinates. They went from -3 to +2. So how many did that move? Take the second one and minus it by the first one. 2 minus -3 is 5. Or if it helps, count it out, -3, 2, 1, 0, 1, 2. You'd count out 5 times. Um, or 5 units, whatever. So take that 5 and multiply it by 1/4, your partial distance. So 1.25. So R is going to move 1.25 units from N. Okay, but first we need to get next we need to get our y coordinates situated. So the y coordinates went from -3 to +3. So I'll do 3 minus -3, and that'll count out 6 units. So multiply that by 1/4, and you get 1.5. So you add together these two values. These aren't your coordinates. You add together these two values to your first point, n. Okay? And so -3 plus 1.25 on the x and -3 plus 1.5 on the y, these results right here are the coordinates of your point R. So let's do one more example like that. On example 5, find point P on AB that is 3/4 the distance from A to B, for A is at 610, B is at 4, 5. So look at your x coordinates. They went from 6 to 4. So do 4 minus 6. That means it moved backwards -2 units. So I'll use a -2 and multiply it by 3/4, and I get -1.5. Then I'll look at the y units. They went from 10 to 5. That moved backwards 5 units. 5 minus 10 is -5. So I'll take a -5 and multiply it by 3/4. Okay? So then I'll take these values and I'll add them to 6 and 10, the first point. So 6 minus 1.5, same thing as plus a negative, is 4.5, and then 10 minus 3.75 is 6.25. That's your coordinate. Those are your coordinates for point P. And then the last thing to cover is skew lines. This is just a definition that just kind of didn't really fit in with the rest of the chapter. But it's skew lines. Skew lines are non-coplanar lines that never intersect. So line L and line M are skew. They're skew because they look like they will intersect at some point if you were to keep drawing the lines, but they're bounded by, or they're contained within the plane, so that's why they'll never intersect. So they have to be non-coplanar lines. If they're coplanar lines that don't look like they're going to intersect, they could eventually. So I hope that makes sense. It's just an extra definition that I needed to add on to the end of this section. Okay? All right, so thank you for watching. Click that like and subscribe button if you learned something, and goodbye.